Right. So yeah, in order to sort of tweak this stuff. So if you're new to Redshift, it's different from something like Octane or Arnold, where you essentially just override the samples itself. So you have these samples. You might be inclined to just really crank up these samples here, but that's gonna make Redshift really slow. And the nice thing of Redshift, which does make it a little bit trickier to use than something like Octane or maybe Arnold in the basics at least, is that you don't just tweak these samples. These are sort of overrides for all of the other stuff. What we can actually do is in sampling overrides, we can change individual samples. We can even change samples on our materials, for example, like ray trace or like the samples on our ray trace subsurface scattering. Each of our lights have samples. So we go in here. So here we have samples for our lights. So all kinds of stuff that we need to do. So let's put some. So in order to be able to tweak that, let's put some AOVs. So let's make a Redshift AOV node. And I have a preset for all my pre-configured AOVs here. So I'm going to apply this, and then I'm going to go quickly over it what we need. But essentially what you would do yourself is just click the plus icon, then set the AOV that you want. But I'm going to really just use my preset. So basic ones that we want, and we're going to remove one of them. We don't want for now. I don't want CryptoMat for now. And we won't use all of these in compositing, but they're these are just the most basic ones that you probably might want to use. So diffuse, these are also the ones that we need to sort of fix our render settings. Diffuse is just going to be the diffuse color, reflections, refractions, global illumination, specular, Z depth, and I generally have it to full depth and Z normalized with a max depth of 50. That seems to be fine for most scenes that I do. Perhaps you need to change this a little bit, but this is just the default that I tend to use. So, and you can change, if you want more detail in there, you could put it to 32-bit per channel. I rendered it with 16, but if you want a little bit more precision, you might go to 32 bits. So essentially what this just is just how much information you have in your pass. So how many zeros after the comma you have for each value. So you'll have a lot more with 32. So in this case, I'm not I'm leaving everything at 16. I guess world position, subsurface scattering. So these are all just the basic ones. And what we want to do is we want to go to output AOV and then drag our configure thing in there. So then this ROP will use the AOVs. And now if we press render here, what we will get is we'll get a drop down menu with all of our AOVs. So let's just do a bucket render. Let's just do this small bucket. It's just faster to work on. Let's just create a snapshot here so we can refer back to it. But we can go through our passes here, and you can see that we can go through our passes, and you can see some might be more noisier than others. So if we then go into our Redshift and then sampling overrides, you can see we have a whole bunch of overrides for certain things. Not for everything, you don't have them for diffuse or whatever, but you do have them for like sample reflection and refraction. So some other stuff needs to be done on the lights as well, because for like to fix some specular highlights, you need to sort of increase the samples on the light, so on the area light. So there's stuff that you need to do there. But let's just go through these settings first. So let's go to reflection. Let's enable reflection, and let's just put it to something like 256. And refraction is probably going to be the same case. So let's also do 256. So it's going to be a little bit slower, but you can see this already cleans it up quite a lot. So if we do another snapshot, could compare. You can see it's already cleaned up quite a bit. So you can see GI probably needs a lot more samples, but reflection and refraction look pretty good. Perhaps reflection could use a couple more, but let's just leave it for now. GI needs quite a lot more, so let's go into our, so you don't do the GI there, you do GI over here. So you have the GI raise, the default is 16, I have my default to 32, but let's also try something like 256, and in irradius point cloud, maybe samples per pixel to like 32. Let's just have a look at if this is gonna make a big difference. So this seems to be a lot slower, or it's not really updating. Ah, okay, there we go. So still seems to be quite. I'm gonna, okay, maybe put my samples per pixel for the irradiance point cloud back to something lower. Let's try 512 on my GI. We can also denoise these passes later, by the way, in compositing. Like GI, you can generally get away with some denoising, because I don't want this to be too slow. And samples on here doesn't really seem to fix it quite as much. So maybe I should just put them lower. It doesn't seem to me make that big of a difference, if I'm honest. Let's turn off the bucket thing. Like, I'm not seeing that much of a difference between, I mean, it's noisy, but it's like now I put it to 1024. Let's just see what this bucket is gonna do. You can see it's a lot slower right now. GI. Okay, I'm just gonna keep it low. What I'm gonna do is maybe, in this case, do a little bit of unified sampling increase. So maybe do like 8 and 32. Generally, it's always kind of a fine balancing act between these two. I think that's kind of okay. Let's, okay, so our specular here has some highlights. Maybe what we want to do is our area light, increase our samples. Also do something like 256. Our mesh light also to 256. Just gonna go over here. Just gonna make this big. Maybe gonna do a full bucket render now. Just have a look what this looks like. Okay, so I'm just gonna go through here. It's not finished rendering yet, but actually I think what we have here is probably good enough for what we have. Again, we can use some denoising in compositing. What you want for that, I'm gonna composit in Fusion, but you can also composit in Nuke later. What we want for that is just you wanna have the diffuse pass here. So the albedo, and we want a normal pass, and then with those two passes we can use the into open image denoiser, and that will clean up a little bit if we have some extra noise. But you can see this already looks quite nice now. And I think I'm already maybe quite liking the way the material looks, so maybe we don't even need to change that. Maybe what I'm gonna try is another frame here. And then we're going to enable a couple of extra things, because some other things we want to do is want to also add some motion blur, for example. This is going to be important. And you can also do motion blur in compositing with the motion vector. But what I do is you should either do motion blur or depth of field in compositing, and I'd rather do the depth of field in compositing. I mean, you can do them both, but it's gonna get quite messy because you need to also motion blur every pass. Yeah, I think what we have here looks pretty cool. Like you can also see the like the reflections here on the stuff. And I think it's still reasonably fast as a render to be able to render this. I mean, your results may vary depending on your GPU that you have, but I say this looks pretty good. So let's enable a couple of other things that we need to enable. For example, we want to do motion blur. So let's go into Redshift. Let's go to motion blur tab, enable motion blur, enable mesh, deformation, motion blur, and instances, particle blur. So probably the transformation steps here is fine. Essentially, transformation steps is, let's say we have an object that transforms. Let's say I make a box here. And I'm gonna keyframe this and it's gonna do like that. It's gonna be the sub-steps that we have between each thing. Maybe I should actually demo this in an empty scene. So 1 second. All right, so an empty scene here. And I enabled motion blur. You can see right now it just looks like sort of fine motion blur. You can see the thing moving around. It's not of a big deal, but now this thing is like, it's not moving that fast. But what if I really crank this up to like, let's say I wanted to really spin really fast. So let's do 3000. Right. So now you can see, like for example, if you have a helicopter, you can start to see a problem here. Maybe let me remove my background here. You get this stepping, right? Because it's moving so fast that, well, the renderer is not really capable to sample the motion blur correctly because there's like the steps between these are way too big. So that's where these steps come in. For example, transformation and deformation. Let's say I put this to 4. Let's reload. See, if I put this to 4, it's going to interpolate more. I could put it even higher. I could put it to 8. You can see now I get like a super smooth motion blur. Probably now you make it even faster and might still work, I guess, to a certain extent. But you can see it's really fast now, but I still get proper motion blur. So I guess if we could do frame duration, it's going to be a much longer thing. So that's kind of why that's kind of where this comes in. So if you have very fast moving stuff, this is where transformation comes in. Deformation particle steps is if you have something that's deforming, let's say particles that are moving, so something that doesn't have a static point count. So yeah, there's that. We don't have anything that moves too fast, so probably we're fine with 2 steps. But if you notice something that's maybe like, oh, I have like really angular motion blur that doesn't look good, then you could choose to increase that. Probably what we want to do is we want to go onto our boxes. So what we have these boxes, our near boxes. Probably what we want to do is do a trail, because we do have the wiggly motion, right, from the chops. So probably we want to recompute the velocity, because the velocity else is going to be grabbed from whatever we had. I think Redshift also does some computation by default by itself, by the way, so maybe we don't even need this. It's going to depend on if you're going to, in settings, you can go to render mesh deformation from velocity attribute. I think if this is enabled, it will grab the velocity attribute. Maybe we don't even want to do that, so maybe we can just leave it off. So that kind of depends on what you're doing. But let's just have a look at what our motion blur here is gonna look like. We should have, and by the way, the uniform samples here. So if you have a lot of motion blur or depth of field, that's where unified sampling comes in, because that's used to clean up stuff like motion blur. So I'm gonna make a little bucket render here. You can see motion blur. Probably it's going to be even clearer in the frames where it's just exploding. So let's just try that out. And also, of course, we have our camera motion blur. And again, also that motion blur is going to be in all of our passes. So you can see why that would be problematic if you're going to composite. You're going to need to reintroduce, because you can reintroduce this in compositing as well, but then you need to do it on every AOV. This is going to be a little of a hassle. But you can see we get some nice motion blur here. So I'd say that's looking pretty good. So yeah, essentially you could render this, but of course we still have some other stuff that we need to do. So this essentially is everything we need to do for this thing. So I guess we could call this here main. Couple of more things we need to do. We need to render the volumetric pass, so for the electricity, and what we also need to do is we need to render the smoke pass. So let's really quickly focus on those. And then we can do our renders and then composite.